Good evening. Okay. So yesterday we have done the interface based on the ADCs. Okay, ADCs is nothing like sensors. We have interfaced LDRs. Okay, na, and some more like sensors like a potentiometer and all. So mainly LDR measures the light intensity. Okay, and the potentiometer, so it is to vary the resistance. Okay, na. So by using both device we have changed the analog values and we have displayed it in the LCD display. Okay, so today also there are like multiple sensors. Let us connect those to the Arduino, and we can display the output in the LCD. Okay, so first thing you need to do is okay, so since we are connecting the sensors, so take the already like pre-connected circuits. Okay, so just search for LCD. Okay, so here there is a 2-wire LCD. Okay, so you can take this circuit, so it is already built. Okay, so this is for mainly for the LCD connections. Okay, na, so it will take more time so when we are connecting the LCD. Okay, to avoid that, so I will just simply take the pre-connected circuits. Okay, so to this circuit you can just add the sensors you needed. Okay, so the next sensors, search for sensors, you will find multiple sensors here. Okay, so yesterday we have already interfaced this one. So this is a photoresistor, also called as LDR, and another one is potentiometer. Okay, na, so potentiometer, so these both we have interfaced yesterday. Okay, and change the light intensity for this sensor, and change the knob. Okay, rotated the knob for this resistor resistance value change. Okay, now okay, so after this we will connect one more sensor. So it is an analog sensor. Okay, now so yes, so search, when you search for sensor you will find multiple sensors. Okay, so here you can take the temperature sensor, so it is named as a TMP. Okay, so this is mainly used for the to measure the temperature in the air or else in the room temperature. Okay, so connect like this. So before the connections I will just go through the sensor working and its applications. Okay, na, so just I will share the screen. Wait. Yes, so all of you open your laptops, open the Tinkercad website. Okay, yes, so the sensor here we are using is LM35, so it is a temperature sensor. Okay, so this sensor is an integrated circuit sensor that can be used to measure temperature with an electrical output proportional to the temperature. So here what happens, based on the temperature the output voltage of the sensor will goes on varies. Okay, and it is proportional to the temperature. Let us say the temperature is 10 degree. Okay, it's an example. So when the temperature is 10 degree, let us consider the input voltage for the sensor is 5 volts. Okay, so in the 10 degree Celsius it will give the output voltage, it will give around 4.5 or 5 volts. Okay, so for 10 degree. Okay, now so when the temperature increases, so let us take the temperature as a 50 degree. Okay, so take an example of 50 degree. For 50 degree the output voltage of the sensor will becomes like 3.53 volts, like that. Okay, now based on this output voltage we will calculate the temperature value out of that. Okay, so when you vary the like LDR, when you vary the light on the LDR, it is changing the analog signals. Okay, same here, when you change the temperature the analog values changes, analog value of the sensor will changing. Okay, so due from using analog values, you can calculate the temperature value. So in the programming I will show the like I will show that formula and all. So after that you can easily identify. Okay na? So how this sensor will work means, okay, so mainly it has 3 pins. Okay na? So it will be like this. So one side it will be curved shape, one side it will be in the flat shape. Okay, so when you keep the flat side towards you, towards your side, the pins, so the left pin becomes supply pin, vs is nothing but a supply pins that you should connect it to the 5 volts, and middle pin will be connected to the output pin. So it is connected to the like signal pin. Okay, so you can use A0 to A5, any pin numbers you can connect the V out pin. So after this there is a ground pin here. Okay, so ground will be connected to the ground pin. Okay, so in the Tinkercad it is easy to identify the pins. When you just place the cursor in near the pin, it will show what which pin it is. Okay na? So no need to like mention like this and all. So directly you can see the pin names. Okay, okay, so using this sensor you can measure the temperature more accurately. Okay na? So when you take an when you differentiate between thermistor and the LM35 sensor, LM35 is a more accurate than the thermistor sensor. Okay na? So thermistor is little bit not efficient sensor when it comes to the temperature. Okay, so there will be around minus plus 10 degrees in the thermistor, but using the LM35 you will get around plus or minus 5 degree. Okay na? Like that. So it will be more accurate than the thermistor type of sensors. Okay, and the sensor circuitry is sealed and not subject to oxidation, etc. So here what happens when you are taking example of a thermistor. Okay, thermistor is fully exposed to the environment. So what it will do means, so this sensor will be damaged within a days. Okay, so and it is and the lifespan of this sensor is very low compared to LM35. Okay, but LM35 having the huge reliability. Okay, it will it can be used around like 1 to 2 years and all. Okay, then the LM35 generates a higher output voltage than thermocoupler and may not require the output voltage be amplified. So here what happens, the thermocouples, so thermocouples these are the different type of sensors to read the temperature value. Okay, so here what happens, these thermocouplers will vary small voltage when it comes to when the change in the temperature, but here in the LM35 when the temperature changes the output voltage will be huge, and it can be used directly. Okay, so but in the case of thermocouplers you should amplify the signals, amplify the output of the sensors, and you should give to the microcontroller. But when it comes to the LM35 you can directly connect it to the controller. That's all. Okay na? So here the V out pin, so it will be connected to the analog pin as you can see here. So it is connected to the analog pin, and the middle pin will be connected to the 5 volts. Okay na? So there will be a 5 volts maximum, and minimum it can be based on the analog signals. Okay na? And the analog signals which is received from the sensors will be like 0 to 1024 steps. Okay na? So it can be converted to 0 to 5 volts. Okay, let us say 1024 divided by 2, which becomes 512 something. Okay na? 512. That means if the value is 512, then the voltage here is 2.5 volts, like that. Okay, so the analog signals and the voltage is directly proportional to the near the temperature near the sensor, like that. Okay, done. So now so come to the Tinkercad. So I already taken the LCD display. So how you should take this one means, just search for LCD here. Okay na? So you will get 2 circuits here. So just you can take this circuit and you can place it here. Okay, so this temperature is a LM35 sensor. So how you should find this one means, just search for sensor, and you will get the temperature sensor here. Okay, so it is named under the TMP. Okay, that is the temperature sensor. You can directly connect it to the Arduino board. Okay, now so I will place this sensor in the breadboard like this. So here you can just see the pins. So this pin is a power pin where you should connect it to the 5 volts, and middle one is V out. So V out will be connected to the signal pin. Okay, now signal pin, and ground will be connected to the ground wire. Okay, now so it is available in the breadboard also. Okay, 5 volts and ground are two pins are available in the breadboard itself, but the signal pins, that is V out, you should connect it to the analog pin. Okay, so there are three connections. So where these type of sensors are used means like in many applications. Okay, so when it comes to the vehicles and all, so in the engine, to check the engine temperature, or else in electric vehicles to check the battery temperature, like that purpose we use the LM35 temperature sensors. Okay, now so in the AC and alls, AC there will be LM35 sensors. So wherever you are checking the temperature, there will be like LM35 or else thermocoupler, both. Okay, so and DS11 also having the same temperature sensor where it measures both temperature and humidity in the using the DS11. Okay, now so that sensor is not available in the Tinkercad, so you can use it in the hardware itself. Okay, so okay, done. So connect this sensor to the controller. Power, so I will change the color of the wire to the red. So power will be connected to the breadboard here. Okay, 5 volts plus positive. So now we have connected the power pin to the 5 volts. Then you need to connect the ground wire. So here there is a ground pin, connected ground pin to the breadboard ground. Okay, so next take the signal pin, middle pin, V out, connect it connect the middle pin to the analog pin. Okay, so here A0, connect the sensor pin to the analog pin. So now we have finished with the connections. So okay, so now see the program for the LM35 sensor. Yes, so this is the program for the LM35 sensor. So the first line is to define the pin number to the variables. Okay, so here we have taken A0 pin as a sensor pin. So throughout the program, wherever you are using this pin A0, so you can just place the sensor pin volt. Okay, okay, done. So next we have taken the variable temperature, and here we have taken the variable type is float. Float means there will be multiple decimal values. So temperature will not will be showing like 22.3, 22, 23.5, like that. So for that type of values we are using float temperature. Okay, now so it is a variable, nothing but a variable. You can take any names. Next there is a void setup. So at first we are printing in the serial monitor. So after this we will go to the LCD display. I will add the LCD program here. You can, after that you can check it. Okay, so first we will display the temperature value in the serial monitor. Okay, so after this void setup, there is a void loop. Okay, so this is a void loop. So see here also we have taken the variable, and we have read on the analog pin. Okay, sensor pin is nothing but a analog pin A0. So the value read from that one is stored in a variable name called sensor value. Okay, now so now we have just saved the analog value to the variable. Then again the variable name voltage. Okay, so this is a formula. Okay, now so voltage, for the voltage variable, sensor value into 5 divided by 1023. 5 is nothing but a input voltage. okay na. 1023 is the nothing but a maximum analog value, okay na. So this is the formula to convert analog value to voltage, okay na. So if you print the voltage means you will get the voltage value across the sensor, and then there is a temperature formula which is calculated into voltage into 100, okay na. So this becomes the temperature value, and the temperature will be in the degree Celsius, okay. Always you should read it as a degree Celsius, okay. So after this calculations and all, directly you can print this temperature variable, okay. So in the serial monitor, first you will display it as a temperature. After that you will display the value. After that value you will display the unit called degree Celsius, that's all, okay na. And the temperature will be showing every 1 second, okay. So this is about the program to display the temperature value in the serial monitor using LM35. So if you have any doubts in the related to connections or programs or anything, you can ask. So already explained the program, so now I will paste it to Tinkercad website. So here you can check the output of the sensor, okay. So now I will click on the start simulation, and here and here how to check the how to set the temperature value in the sensor means just click on the sensor. Here you can adjust the sensor values, okay na. So for the first program we are not displaying the value in the LCD, okay, don't see the LCD. So open the serial monitor, yes. So here you can see the temperature value, okay na, like this. So you can change the temperature value by moving this cursor, okay. So now it is showing like 116, okay. So like this you can check the temperature values using the sensor, okay. And there is one more program for the LM35. I will show it in the Tinkercad itself, okay. So here the program calculations is little bit wrong, so I will show the correct program here. Wait a minute. Okay, so see here. So now it became correct, okay na. So there is a small change in the formula. So what it is means, so here the voltage formula is same, okay na, 5 volts divided by 1023. This is the analog value, okay. So for the temperature, so there is a small changes, that is voltage minus 0.5 into 100, okay na. So this one was missing in the last program, so that's why it is reading wrong value, okay na. So and here in this program there is also a LCD program. Okay now, so I will like share this program in the Google Classroom. Okay. Okay, so I will share the same program in the Google Classroom, so from there you can just copy the code. Okay, so this is the actual program for the Google like temperature sensor. So these three lines are for the LCD display. Okay now, so after this we have taken the temperature variable, so and we have set the initial value as a 0. Okay now, so after this for the we have initialized the LCD, and then so temperature, so LCD in the first line we have displayed temperature. Next, so A1, we have connected the temperature sensor to the A1. Okay now, so A1 will be input, sensor is the input device, so we have connected the sensor to the A1 pin. So after this, so analog read A1 pin, and for the voltage calculation, the which is ADC value into 5 divided by 1023. So this is the maximum input voltage, this is the maximum analog value. Okay now, so after this temperature is equal to voltage, so the already we have calculated the voltage, that voltage minus 0.5, okay, into 100. So this is a formula to calculate the temperature value. Okay, after this, so just you can print the LCD. Okay, print the value in the LCD display. So in the first line you are displaying the value name as temperature. In the second line display the value variable name. Okay, and after the value C is nothing but a Celsius. Then so every 1 second it will update the temperature value. So this is the program, and so here you can check the output. So now the temperature is showing 24.78 and the actual temperature is 25. So here you can see, like in the sensor it is 25 degrees Celsius. Okay now, so there will be slight variations, so which comes under the like plus or minus value. Okay now, so I already told you, so there will be like plus or minus 5 degree when it comes to the actual value. Okay now, so now I will vary this temperature. Okay, so I have set it for 95 degrees Celsius. Here you can see 95 degrees Celsius, and here it is showing 95.16 Celsius. Okay now, so there is a small like small variation about 0.2 Celsius, 2 Celsius. Okay, that's all. Okay now, so after this you can just simply add the conditions. Okay, so if the temperature is greater than like 30 degree, give the warning signal, like that you can do, you can apply the conditions. So how you should apply the condition means, so after the formula, after all the calculations, so you will get the temperature value. Okay now, so after this after getting the temperature value, you can just write the conditions. Okay, so I will write it after the display and all. So here you can just simply write the if condition. If temperature, sorry, if temperature, this variable, this is a variable name, temperature is less than 20 degree. Okay, less than 20 degree, so just display temperature low. in the serial in the LCD. Okay, so here already we have displayed the value. Okay, so I will display it in the both in the first line. Okay, so after this you can just display high temperature, low temperature in the second line. In the first line it will display temp, that is nothing but temperature, and then the value, and then Celsius. Okay, like this. In the second line, so display the, for when the temperature is less than 20 degree, display low temperature. So let us set the cursor for 0, 1, which means second line. So here it should show low temperature. Okay now. So after this, close the if bracket, write the else. So if the temperature is greater than 20 degree, okay now, greater than 20 degree means it should show high voltage, high temperature. So like this you can apply the conditions, or else you can just turn on LED, turn off LED, like that also you can do the operation here. Okay now. So after this I will show that one. So here also we should set the cursor in the else part. Okay now, or else it will display in the first line. So when you set the cursor means it will show the in the correct line. Okay, so we'll see the same program output here. So now the temperature is greater than 20. Okay now, so the temperature is 24.78. So it is showing high temperature. Or else I will move the temperature value to 97 degree. So now it is showing high temperature. When you reduce the temperature below 20 degree means it will show low temperature. Okay now, so you can see here the temperature value is minus 33. So that's why it is showing low temperature. Okay, so like this you can apply the conditions to the temperature sensor. Okay, so think like you have connected the sensor to the battery. Okay, the battery maximum temperature is 60 degree. Okay, so after the 60 degree, that battery gets damaged, like that. So you can limit the battery charging to the 60 degree. So after, if the battery temperature crosses the 60 degree temperature, then cut off the battery supply, like that. Okay, like that you can do the applications. Use the temperature sensor as a application for the electric vehicle. Okay, so for the same program, let us connect another one LED to indicate. So I will take two LEDs. Okay now, one is green, one is red. Okay now, so pin number I will connect it to, like, which pin number is free in the LCD. Yes, the pin number is 6 and 7 are free. So we have not connected anything to the pin number 6 and 7. Okay, so I will take this pin number 6 and 7. 6 will become output pin, then 7 output, 6 and 7 will be output. So here, no low temperature, we will make the red LED digital write, so 6 high, and 7 should be low here. So we will turn on red LED and we will turn off green LED here. Okay, 7. So when it is low temperature, the red LED will the green LED will turn on and the red LED will turn off. When the temperature is high, okay na, so when the temperature is high, that means in the else. So else what happens? So I will change the pin number here. Okay, I will make it as 7 and make it as 6. So here what happens, the red LED will turn on, green LED will turn off. Okay now, so this is the program. So let us change the, add the LED to the circuits. So take two LEDs, one here, another one I will connect here, or else I will connect both the LEDs here. Okay, so and just change the color of LED. Okay now, so one will be red, one will be green, make it as green color. Okay, so if the green color is on means the temperature is low, that means the temperature is below 20 degree. If the red LED is on means the temperature is high, which is greater than 20 degree. The temperature is greater than 20 degree, like that. Okay, so now connect the cathodes to the ground connection. So cathode must be connected to the ground connection, and this cathode should be connected to the ground connection. Done. So after this we have to connect the signal pins. Anode red LED will be connected to the pin number 6. Sorry, pin number 7. Red LED should be connected to the pin number 7. Okay now, then green LED should be connected to the pin number 6. So here we have not used resistor, so it may show error. Okay now, so let us check. Okay, so it is showing so LED we have used without resistor. So let us connect the resistor here. So cathode, so either you can connect it to the cathode or else you can connect it to the anode, both are correct. Yes, so now I will click on the start simulation. So there is no warning here, and here you can see there is a red LED, so that means the temperature is high. Okay now, so now I will set the temperature. Okay, so now you can see the red LED is off, green LED is on, that means the temperature is low. Okay, so like this you can just add or remove the devices in the circuits. So now I am connected, interfaced multiple devices like LCD, okay now, LEDs, temperature sensors. Okay, all these are multiple devices. Before this we have just interfaced single devices, like we have connected only LCDs, we have connected only LEDs. Okay, so now we have integrated all the devices. So till further you can just increase the number of devices, and you can lead it to the project levels. Okay, so this is a simple temperature controlling interface. So you can just replace this LED with the real relay modules, where they will control the fans and all. Okay, so in the real time you can control the fan using this temperature sensor. If the temperature is greater than 30 degree, you can turn on the fan. If the temperature is less than 30 degree, you can turn off the fan, like that. Okay, so for the real time applications you can use the controller and this temperature sensor. Okay, so after this interface I will show one more sensor, and remaining sensors, so you should work on your own. Okay now, so sensors, there are multiple sensors. I will show soil moisture. Okay, I will show the soil moisture now. So remaining sensors like flex sensors, force sensors, gas sensors, tilt sensors, so these sensors should be connected by your phone. Okay, now so you should connect these sensors to the Arduino, and you should write the program, and should display the values in the LCD. Okay, that's your work. I will give the assignment questions, solve that one. Okay, na. So the like program will be same for every analog sensors. The changing is connections. Okay, na. So all the sensors is having two pins. Okay, check that one. So here you can see there are two pins. It says 2 and 1. So how you should connect this sensor means, so like similar to the LDR. So LDR is having two pins. So you have connected resistance to the ground pin, and LDR positive pin to the 5 volts, and signal pins will be connected to between the sensor pin and the resistor, like that you should connect these sensors which is having two pins. Okay, and this gas sensor having the 6 pins. So just check the pins. Okay, now so here it is showing A2, H1 and A1. Okay, same here B1, H2 and B2. So just check the pin connections, and try to connect these sensors to the Arduino. Okay, so now I will show the simple another simple analog sensors which is having 3 pins. Okay, so here you can see there are 3 pins. So one is VCC, which is connected to the plus 5 volts, one is ground pin, and one is signal pin. Okay, so take new example. Go to the desktop and click on create circuits. So soil moisture, like you can use it in the like agriculture fields, or if you are having garden in your homes, and plants which are in the pot. So they are here you can use the soil moisture. Okay, na? So to check the water content in the soil, and there are multiple projects related to the soil moisture sensors like crop monitoring system, or else plant monitoring. Okay, and automatic water cutout, and automatic irrigations. Okay, like these projects you can use the soil moisture. The first thing we have to use the take the Arduino Uno, place it here, and the sensor is soil moisture sensor. So here just you can take it. So I will show the simple connections. Okay, so VCC will be connected to the plus 5 volts, so after this there is a ground pin. Take the black wire, connect the ground pin. Okay, so after this there is a signal pin. Connect the signal pin to the analog pins. I will use the A0 pin. Done. So this is the connections. It is simple, so you can use it directly. Okay, without any breadboard or any devices and all. So now we have not connected any displayed like modules, so we will print the value in the serial monitor. Okay, so for that go to the code, make the blocks as a text, click on the continue, Yes. So here you should write the program. Void setup. So program will be simple, like just you are using the only one sensor, okay, and displaying the value in the serial monitor. For that, first you should mention serial dot begin 9600. Okay. So after this, we have connected the sensor to the pin number A0. For that, you should mention the pin as a input. A0 input. Okay. So this is the program inside the void setup. So after the void setup, write void loop. Okay. So here first you need to take the variable to store the soil moisture value. Okay. So since it is an analog sensor, you should write analog read A0. Okay. So after like reading and storing it in a variable, just you can directly print it in the serial monitor. Serial dot print soil moisture. Okay. So after this, serial dot print value delay 1000. Okay now. So now you can start the simulations. Directly you can see the value of the soil moisture. Okay now. So now it is showing like displaying in the like one single line. So this should print it in the second line. That's why you should write the print ln. Print, you should not write only print, so you should add the ln to the print. So now it shows the value, new value in the next line. Okay, so here, so initial it is showing 0. So to increase the soil moisture, just click on the sensor. Here you can increase the moisture level. Okay na. So now I will increase the moisture level to the maximum. Okay. So I have increased the sensor value to the maximum. The value is 876, like that. Okay. So when you keep it in the middle, okay, let us say there is a normal moisture means, so now it is showing 393, similar like near to the 400 value. Okay. So for this you can just use the like relay modules, buzzers, LEDs, or anything, any devices you can connect, and you can write the conditions. Okay, same which I have written for the LM35 sensor. Okay na. So for this also I will show like to turn on turn off the LED, or else you can use another one device, that is buzzer. Okay, so here it is called like a piezoelectric buzzer. Okay, so here you can see piezo. Okay, piezo, so it is a buzzer. The full name is piezoelectric buzzer. Okay now. So this is the buzzer which gives the sound output. LED gives the light output, but here the buzzer will give the sound output. So just you can add it to the Arduino board. So positive will be connected to the pin number. So I will connect the pin number to the 10, and ground pin will be connected to the ground pin. Okay, so there are total 3 ground pins in the Arduino, so you can connect it to any pins. Okay, I will connect it to the ground pin here. That's all. So after this connection, like you need to change the programming structure. So for this is a simple program. You can add the if condition. Okay, so add if. So the variable here is a value. Take value. if value is less than let us say 300. Okay, so let us say 300. So for this, buzzer should turn on. Before writing it in the condition, you just first you need to mention the pin as the output. Okay, buzzer is the output device, so you should write pin mode. So we have used a pin number 10 for the buzzer, so 10 output. Okay, so after this, here you need to write digital write. So we have used pin number 10 comma high, bracket close, semicolon. Now close the if bracket, write the else. So here what you should do means you should lower the pin number 10, so make it as low, close the bracket, that's all. So this buzzer will sound like vibration. Okay, so you can hear the buzzer sound. Now I will click on the start simulation. So now we have done with the program. Okay, now so when you click on the start simulation, so the sound is coming. Okay, so the value, let us check the value here. The value is 0. Okay, that's why the buzzer is on. So now change the value to the greater than 300. So the value is 281, but still the buzzer is on. I will increase the moisture level. So now the moisture level is 781. That's why the buzzer is off. Okay, now like this you can connect multiple devices and write the conditions and get the output. Okay, so check the program and try to make the connections. Okay, so for this interface you can just add the LCD display. Okay, so that is the assignment for you. Just add the LCD display and display the soil moisture in the LCD. Okay, now and also you can display the soil moisture value in the percentage value. Okay, so let us say now you are set the value to the here. Okay, so maximum there will be, it is showing 100%. Okay, you can show the maximum value as 100%. So when the value is in the middle, okay, you can show it as a 50%, 50% soil moisture, and if the value is 0% means you can show it as a 0%. Okay, now so when you vary slightly, you can show the percentage values, because always the moisture, humidity, all are measured with the percentage value. Okay, now that. Okay, done. So this is for today's class. So I will share the assignment questions, try to solve those one. Okay, now